So, what is hardness? Hardness is that it is due to the presence of some soluble salt in the water sample. So, it is due to the presence of some soluble salt on water sample. Now, depending on the the salt, depending on the salt, the hardness are divided into two parts, that is temporary hardness and permanent hardness. Okay. But it is not permanent, it can be removed, but the removal of temporary hardness, it is very easy. Okay. First one, it is boiling and then it is filtration. Okay. But the removal, that is permanent hardness, it can be removed by, there are some method by which the permanent hardness are removed. So, first of all, temporary hardness are removed by heating. So, when the temporary hardness are due to the presence of bicarbonate and presence of calcium bicarbonate and magnesium bicarbonate in water sample. So, temporary hardness is removed by heating and then filtration, and also by heating with slake lime and then filtration. So, temporary hardness by one, that is heating, not only heating, it is boiling plus filtration, filter. Number 2, that is slake lime, heat plus filter. Okay. Now, I have told you that the permanent hardness is due to the presence of chloride and sulphate, Cl and SO4. Okay. Now, these chlorides and sulphates cannot be removed easily. Okay. So, to remove such anions from the water sample, we have to follow some basic methods. So, the basic methods are: number 1 is washing soda method, and number 2 is ion exchanging method, Number 1, that is washing soda method and ion exchange method. Okay. So, first of all, the reaction will follow, that is washing soda method. Now, washing soda method, that is, it is the composition, that is sodium bicarbonate. Now, when some chloride salts is present, then what happened? Suppose calcium chloride, I am rubbing this portion. So, the point is removal of permanent hardness. Removal of permanent hardness. That is washing soda method. So, Na2CO3 plus calcium chloride. So, calcium carbonate plus twice NaCl. Now, NaCl is not harmful to us, okay, and calcium carbonate, it is deposited. Okay. So, as calcium carbonate is deposited in the bottom of the experimental chamber, NaCl is not at all the soluble, then it is the removal of the permanent hardness by calcium carbonate method. Another one, that is, suppose it is carbonate Na2CO3 plus any sulphate salt is present there. So, what is the sulphate? That is, suppose magnesium sulphate is present. Magnesium sulphate is present, then it will produce magnesium carbonate plus sodium sulphate. Okay. So, this is the second method, which is for the sulphate. The precipitation can be removed by filtration. So, the calcium 2 plus, magnesium 2 plus, these are removed from the water sample. Okay. So, this is the removal by washing soda method. Next one, have you understood up to this? That is how removal of permanent hardness by first one, these are the washing soda method. Washing soda method. Okay, you may also write the equation. Next one, by the ion exchange method. As ions are responsible for the hardness, so if we exchange the ion by any other ion, that means suppose magnesium is harmful, then we will exchange the ion by some other ions, so that it is no longer harmful to us. So, it is called the ion exchanger process. Two types of ion exchanger are there. One is inorganic ion exchanger, that is called Permutate method, okay, and the another one is organic ion exchanger or synthetic resin method. So, ion exchange process, I am rubbing this portion. So, it is washing soda method. Next one, ion exchange. It is also having inorganic ion exchanger, that is Permutate, and organic ion exchanger, welcome Dia, another organic ion exchanger, it is ion exchange resin. Okay. So, these are the two methods by which removal of permanent hardness is done. So, first of all, the question is, what is Permutate? It is sodium aluminum silicate. What is Permutate? It is an complex inorganic salt. It is sodium aluminosilicate and the formula having Na2Al2Si2O8. Permutate Na2Al2Si2O8 XH2O. The name is that sodium aluminosilicate. Sodium aluminosilicate, hydrated, it is hydrated. So, it is the Permutate. Now, you can see that in the formula the sodium is there. Okay. Now, this sodium is exchanged with the complex, that is the salts, that is calcium, magnesium, so that it is no longer harmful to us. Okay. Next, so the process of softening of water in a cylindrical vessel where the sand, the grape particles and the permutate is there, and then hard water is introduced through an inlet tube, and then it reaches at the bottom the pail, that is the pebbles, remove the impurities which is already suspended on this, and comes to the contact to the permutate, which exchange the calcium and magnesium. So, here it can works as a cation exchanger. You can see that, and general representation of the permutate is this part Na2Z. where Z is Al2 Si2O8 Si2O8 8H2O or XH2O, and this is the name of this compound is that zeolite. What is Z? Z is zeolite. Okay. So, this formula, that is the Al2Si2O8 XH2O, this is the formula, that is zeolite. Now, coming to the reaction of this, when permutate is applied to the sample containing hard water. Now, Na2Z and the permanent hardness is due to the presence of some calcium or magnesium salt. So, calcium salt, then it will form that Ca2Z or CaZ plus Na2 plus 2Na plus. Okay. But Na plus is no longer harmful to us, and the calcium which was present in the salt sample, it was make compounds with the zeolite, okay, or the permutate. So, this is one. Next one, Na2Z plus magnesium salt Mg2 plus. Again it will form compounds with Mg2Z plus 2Na plus. So, the water sample again it is not harmful to us. So, these are the exchange of cations. Okay. So, this is called cation exchanger. Cation exchanger. So, permutate is the cation exchanger. What is the formula of permutate? Na2Al2 Si2O8 XH2O, and with left of the Na2 part it is Z, that is called zeolite. You have seen here the name of zeolite. Now, what is the, there is a recharging is required. What is this recharging? Because there is a limited amount of zeolite is used, limited amount of zeolite or permutate is used in the process, that means in chamber. Now, as the sodium ion are exchanging every time, so the sodium ion will ultimately becomes ended, that means there is no sodium to exchange with the calcium. Then the function of the permutate method will stop. Okay. So, we have to recharge the sample, we have to recharge the sample, so that the work activity of the process is continued. So, for this here NaCl solution is added. I will show you how the pictures is look like in the permanent hardness removal. So, NaCl solution is added to recharge the permutate. Next, follow the pictorial diagram of permutate process of water softening. The thickness should be same. This is the inlet pipe, that is hard water, this is the soft water. Now, in below, in the chamber at below is the coarse sand and then the permutate. So, the hard water first going towards the coarse sand or pebble, and at that layer it is the permutate, and this portion full with soft water. And as this layer contains hard water, that means permutate, there is another NaCl solution is added to the permutate, so that the process is continued. And there is a pipe where, that is the waste, the impurities or suspended particles which was on the hard water. So, this is a cylindrical chamber, this is the coarse sand is there which can extract the suspended particles or impurities. Next one, the permutate is a Exchanger ion exchanger. Now, here NaCl solution is also added. NaCl solution is also added to recharge the NaCl, to recharge the permutate. Okay. So, this is the process. It is the heading is that removal of permanent hardness by permutate method. So, just make a revision of today's class, that is hardness are of two types, temporary hardness and permanent hardness. Temporary hardness is due to the presence of the soluble salt like bicarbonates, which can be easily removed. Okay. Now, the next one, that is permanent hardness, it is due to the presence of some chlorides and sulphate in the water sample. Now, temporary hardness is due to the it can be removed by boiling and then filtration, both the process, and the reaction is that calcium bicarbonate produces calcium carbonate plus CO2 plus H2O. If calcium bicarbonate is there, if magnesium bicarbonate is there, then it will also form magnesium carbonate. Now, these carbonates are insoluble in water and take deposition on the bottom of the container. Next one is the permanent hardness. Permanent hardness is due to the presence of some chloride sulfate, that means calcium chloride, magnesium chloride, calcium sulphate. Okay. So, these are also soluble in water. Now, how to remove the permanent hardness? I have told you the two processes there. One is using soda ash method or washing soda method, that is if calcium chloride is there, then when it reacts with sodium carbonate, it will produce sodium chloride and also the calcium, that is sodium carbonate plus calcium chloride forming sodium chloride and calcium carbonate. So, calcium carbonate can be easily be removed by filtration. And next one is that by removal of ion exchange method. Now, ion exchange are of two types, one is inorganic ion exchanger and another one is organic ion exchanger. Now, inorganic ion exchanger I have told today, it is also called cationic exchanger, because you can see the reaction, it is the calcium salt. Now, after that the calcium is removed from water sample. So, it only removes the hard cation present in the water sample. So, the permutate method is the removal of permanent hardness, here only the cation exchanger, and in below I have shown you the diagram of the removal of permanent hardness by permutate method. Now, what is permutate? The question, 1 marks question is that what is permutate, what is zeolite? Now, permutate is the sodium aluminosilicate, and the formula is given, that is Na2Al2Si2O8xH2O also, and the Z is generally represented as NaZ, where Z is Al2Si2O8xH2O, it is zeolite. Okay. So, these are the compounds. Okay. So, next day I will told you about the next method, that is the removal of permanent hardness by organic ion exchanger or organic resin. Okay. Any confusion up to this? Dia and Oishiki. Okay, thank you. Thank you everyone. Okay, so bye.